Hello, this is David Birch at Star Path School of Navigation in Seattle, and I want to do a comparison of the GFS model predictions with the actual ASCAT forecasts. And I want to do this for a couple reasons. One is to show how to do this, but second of all, I've made several notes recently, I think important notes, to show that the GFS can seriously underestimate the winds of a tropical storm and hurricane. And I think I did stress that that's especially the case when the system is just beginning or developing rapidly. But here I want to show that after the system's been watched for a while, that the GFS can actually be a good guideline. And so we have to do several cross checks to be sure that the data is usable in routing decisions. But once you've made a couple of those checks, then you can go ahead and route around it with a weather routing program. So this is Expedition here, showing Expedition, and I have imported, and this is back from the date is July 14th, and this is data at 1911. And the reason I'm using that time is because that's when the data was available. And let me just make a quick reminder how this ASCAT data works. And if we look, this is the ASCAT page where these data are available online as graphic images. And then you see, like, here's a remnant. This is using the ASCAT satellite. There's also RapidScat. Here's some kind of hot spot here going on. So there's a nice one actually right there. In fact, I'll come back to that one. But here's the point. Here's the important point to make. We have to always figure out what time this page is for. Notice that this page of data is updated 1913 UTC. So let me go back. So this whole page here was updated at 1913, and these are updated every hour. But this includes the present hour plus the past 22 hours of satellite passes. So when we look at a particular pass, like this would be a good case to study, and I'll probably do that one actually next. But here it says this is when the page was updated, 1913, July 17th, and this was the UTC of the pass, which was 1651. 1651. So 1651, and so that's before 1913 and within the past 22 hours. So that means that the actual date of this pass, this is a fairly recent pass. This was updated just at 1913, and this was 1651. So the date of this data is actually 1651 on July 17th. Often you'll find that this number here is bigger than this number, and when that's the case, it's from the previous day. But anyway, here will be a nice case, and I'll come back to that one. So that's where we get the data. Then you just right-click and save the image, and then that's the one you're going to load into a program to check. In this case, I loaded one that was valid at 1911. And then if we go up here, though, on the top of this one and look at this one, you see this is 1911 on a page that was July 15, 1604. So this means this 1911 data had to have been from July 14th. So we're looking at a picture of this storm. I think, let me check, I think that's Celia. That was valid at ASCAT data, real measurements of the wind on the ocean with a scatterometer at 1911 on July 14th. So then we get the GRIB data from the earliest GRIB data. And so the earliest GRIB data would be 18 Zulu. So if I go back here, I went back and got the 18 Zulu data. That's a forecast starting at 18Z, so that's 0. So this is GFS forecast only 1 hour old. So I go up to an hour, and in fact you could actually go here and set the time to match. So then Expedition will interpolate between the GFS times. The GFS are only giving you forecasts. I mean, you can click here and it says every hour, but the reality is the GFS model only gives you data every 3 hours. So when we sort of magically go to 1911, that means the program Expedition has taken the winds at each of these spots. Like here's it at 1800, then it goes to 2100. Right, and it averages those two in both speed and direction, and then puts what it is at 1911. So this is an interpolated forecast between the 18Z and the 18 plus 3, 21Z. So that's what's laid here, and then I've loaded this image with this feature here on charts, images, load images, and that's the image I stored and saved, and I just brought it in. And then you have to close. Then you have to georeference it. It takes 2 clicks, and I'm going to have a different video showing that process. But here's now, let's just make this comparison. So here's we want to make the comparison of what's forecasted. Now these if you go to the picture here, you've got the conventional arrows, like that little symbol in the ASCAT data. That's nominally 20 knots, just like that's nominally 20 knots. But that means 17.5 to 22.5. That's a symbol. Does not mean 20 knots. 17.5, 22.5. So that we can only make that level of comparison here, except in the here you can actually go here and see what the GFS, this one that says 20, see this little arrow right here, the GFS is actually saying that wind is 21.4. I don't know if you can see that. If you come down here, this one is about 23.3. Shows at 25, but it's actually 23.3, and so on. So you have that nice tooltip for looking at the GFS forecast, but you don't have that for this other one. We have to go by the colors, and the color band is up here. Here, it's on the top of the page. So you see it's going from dark green to yellow. That's switching from 20 to 25. So this is green going to yellow. So this is right below 20, and this is just above 20, and this is just below 20. So this is floating around in the forecast at about 20 knots. And so here's the point. I mean, this is actually a very good GFS forecast out here. You see the wind, this is a forecast in the vicinity of this tropical storm. You know, it's quite a few days old now, and it's been watched and studied, and it's pretty good data. You see, 20, that's 20 knots. Now you come down here, and you just keep going in. Now this is the, okay, I have another picture here. Maybe I can here. I made a picture here so we can see this. There you see, so when it's going to brown, orange and brown, so dark red going to bright red, that's going into 30 knots. So this is around 30 here, and sure enough, this is 30, this is going into 30, and so on. And the wind direction's pretty good, not exactly right, but pretty good. Out here it's almost precise, here it's almost precise, here it's off just a little bit. And then we can go on down and look at the these other colors and so on. So all in all, I mean, it underestimates it some. See, the real, in this case, for example, this shows 20 knots, 25 knots in this area here, where in fact the real wind was 40 some knots. This is 40 around in here, 45. So it underestimated it there, but that's but here's 30 and this is 40. So the GFS did underestimate the wind speeds, but all in all, if you hopefully you're not navigating in here, you're navigating way out here somewhere, right? At the worst. And so it's all in all, I'd have to say that's pretty good. And that's if you stay a good distance away from this thing, you're tactically okay. Now, what is a good distance away? We go back to the so-called 34-knot rule, 34-knot wind rule. The National Weather Service and Navy recommends that we stay out of the range. In other words, where this is to be dangerous and change rapidly, they say stay away from the 34-knot wind zone. And you get that from these tropical, where is it? Oh, maybe I thought I had that right here. Oh, maybe not. Okay, you get those. You'd have to just go to the National Hurricane Center, or maybe I have it on a different computer. Let me look at a different computer here. Oh yeah, I have a different computer. So this is actually on the base computer. The other ones are actually running on a virtual machine. So this is Tropical Storm Celia, and I'm going, today's like the 17th I'm doing this, but so I'm going back. I started this and didn't get to finish it. But here is the storm, and the best data, these are the tropical advisories, which have the most detailed pictures of what the wind speeds are. And we have videos on how to get these underway. So this is the storm, but this was at 1500. So we only have this data at 1500, and then we go all the way up to 00 on the 15th. So this is a little bit earlier in the life of the storm. Not exactly a comparison, but you see what they're telling us here. They say this 34-knot wind speed. 34-knot wind speed extends out in the northeast direction from the center of the storm, and this is a little bit shifted from here at 1900. It's where does it say how fast it's moving? Well, it says here somewhere how fast it's moving, but I don't see it right this minute. But 45 maximum sustained winds 45 knots. That's more or less what we saw, gusts of 55. But here's these zones, and I'm just showing one way on expedition to kind of take a look at that. But it says in the northeast direction 110, 110. So you'd come back here to this picture, and northeast direction is here, and then expedition has this tool, where is it? Here, set, and then you can, and if you do that, you can just set a nice little ruler like that. And so here, and then here's a ruler here. So, well, actually it's a little hard to see. Let me just see if I can move that ruler. No, I can't. Let me grab it here. Oh, I'm not being able to grab that guy. Well, maybe I can't. Well, anyway, it's about, I drew that at about 100 miles. That's about 90 miles. So I just want to illustrate this tool that you can then look at the position of the storm, look at the report from the Hurricane Center Advisory, draw that line out here, and that's the region that's supposed to be 34 knots of wind, out about 100 miles. And then these were out about 60 and so forth. So you see these little arrows are drawn out, and that means this quadrant. That means from this area around to here. Around like that's where they say it's 34 knots of wind, and that's pretty close. It's all pretty close. So that's the illustration of how to do this comparison. So, and again, I want to stress that even though the details or the strength of the peak winds can be wrong, if you make a few checks, like just compare the advisories to the range of the winds, right? And if that looks about right, then chances are you can do some, some routing using these winds around the, you get out 100, 200 miles from this thing, you probably have pretty good predictions from the GFS to do your tactical routing. That's the main point I want to make. And so later I need to come back and just maybe show a little more detail about how you actually load this picture and georeference it in this program Expedition. Then I'll make one more video to show how you do the same thing. You can do this also in open CPN. So this is a real high-end program, this Expedition, but then Open CPN is a free program. So it's another way to do it. So that's where I'll stop for here.